Welcome to this session on private data platform for private AI. Just to know, just to make sure that we hit the right level of details, just by show of hands, can you tell me how many of you are either developing some AI stuff or doing something with AI? It's pretty good. And how many of those are using public AI models and how many are private AI installations? Like something
Public? Private? That was there. No?
Perfect. All right, I'll make sure that we touch on both those things. This is me. I have about close to 30 years now in data management. I was with EY as a advisory role on the data architecture, data governance, and stuff like that. Then I was at Morgan Stanley running the institutional securities data division. And now with VMware Broadcom, I'm helping our clients understand our data products, mainly from AI and data lakehouse kind of stuff, and see how to get the most out of our products. And this is Don.
Hi, Dan Basket. My face is not that wide. So I have 30 years experience as well. Started at Sun Microsystems back in the day. I really got into data warehousing and joined Greenplum and then got into Hadoop and just progressed all through the cycle of data products. And now I run technical marketing at Tanzu.
Yep. So between both of us, we kind of have the experience helping our clients and also influencing, working with our R&D and product engineering on what the industry wants and then what we should be building towards, right? So this is kind of like trying to get all those expertise into a 40-minute session so that you can take away something meaningful from this. So before we get started and dive into details, Dan, why do we build software, like any software?
Want to automate a process, in this case, probably some business process.
Absolutely, right? So basically, you write any piece of software to automate a business process. You were manually doing something, whether that is like the room temperature is going high, you want to turn on the AC, you want to automate that, or it's something like, I want to find an object of interest in my surveillance images, and I want to take an action on it, right? If it's simple software, the traditional software is more like if then else rules. It's maybe more complex, but if you really drill it down to what essentially it is, it's sort of like if this, do this, right? But this sort of use case requires more than that. This is where we need the intelligence in the software. You need more than if then else rules. You need some sort of software that can mimic the human intelligence. For example, if you want to do something like this to get through all the noise, if you're taking thousands of images and then you want to get through all the noise and get to the action, you need something like an AI model to help with us. But whether it is you're doing with a software or manually, you need a lot of data to do this. First of all, you need all these pictures, right? And then you need stuff like coordinates. Like an example is, let's say I want to look at what's going on in 2-mile radius of White House, right? If I am part of the Secret Service and I want to keep an eye on that, right? What are the things I need to know? I need to get images. I need to have geospatial coordinates, so I know exactly what is 2 miles radius and what's within that. Then I need some stuff about what went on, logs and communication with my other agents and stuff. And then some sensor feeds. I have cameras, I have sensors all over the place, so I need all of that. And then in other cases, I also need raster data, like what is the elevation, what is the terrain, and things like that. So the message is that to do anything, whether you're manually processing or using an AI or a traditional software, you need a lot of data. But we all know this is growing exponentially, right? Like as you're collecting data from these satellites or drones, you're not just collecting one picture or 10 pictures. And in fact, if you're collecting a small amount of data, you really can't make a sense out of it, right? If I just have one picture, I can't tell you whether there is a threat or not. But if I have hundreds of pictures, I can look at the pattern and say, oh, there is something going on here. So essentially what's happening is, with all these modern use cases, your volume of data, the volume needed is becoming really, really high, right? Your volume increases often terabytes and mostly running into petabytes. In fact, I have a use case later I'll show you where our customer is doing like 300 terabytes a year, which in a couple of years you will quickly cross petabytes. And it's not only the volume, it's also velocity of the data. Imagine the drones that are taking pictures. Imagine the IoT devices and all the stuff that you're collecting from the field, right? The velocity of data you're getting is also fast. And variety, just in this example, we have images, we have sensors and IoT feeds come in JSONs and XMLs, like semi-structured data. And then you have logs and stuff, unstructured data. So there is different types of data, right? 3 V's that most of you are familiar with for the big data, right? Volume, velocity, and variety. That's what is hitting us. So you need to process all this data to make some sense out of it, right? And we all, in fact, most of us here, and nowadays even most public, understands that AI can solve these use cases. It can process tons and tons of data and get meaningful insights out of it, right? And the common perception is that you have all this data, you run it through a bunch of AI models, right? It can be advanced models like your GPT models or something like that, or even basic model like your regression, random forest, whatever, depending on your use case. And then you get output. In this case, the understanding would be like, I have some data from all my drones and stuff. I pass it through a bunch of maybe, let's say, large language and vision model, and I get my anomaly flag. And there is also common understanding that it's not just taking and just pushing it through some models. There is some activity involved, right? Whenever you think about an AI project, you definitely are thinking about model development, but this is done usually by foundational companies like your Google, Meta, XAI, Anthropic, and those kind of things, right? Most enterprises probably start with model selection and training. So you will go look at all the available models, and you try to figure out what is the right model for your use case, and then in some cases, you need to train those models to make use of your data set. And then you'll probably get into ensembling models, basically like using a bunch of different models, putting together and making sure that you get the right fine-tuned output you want. And then you deploy the model, you take it through the whole monitoring process, retrain those, because there could be context drift, data drift, and all that stuff. So this is a typical AI thing that I'm sure most of you are familiar with that. And this is also the common perception that an AI project involves these things. The reality, working with lots of customers in federal and I cover public sector and healthcare accounts for our business unit. So from what we have seen in the industry is that it's a lot more than that. Actually, a lot of activity is spent on pre-processing the data, right? Why? Because as human beings, we can take 2 pictures, and even if one is blurred, one is clear, you can still make sense out of it, right? We can make sense out of it. But a model doesn't work like that. Depending on what model you are using, you need to have processed data in the way that model wants it. Like with CNNs, there were some problems, and then we got this features pyramid network type advancements and all that to solve for those things, right? I have spatial information, I have semantic information in my data. How do I capture those, right? So to really use an AI model successfully, it can be any model. Like I said, can be a regression model as simple as just predicting your house price, or a vision model. You still need to cleanse your data, pre-process it, make sure that that data fits what your model wants, right? And not only that, there is also a lot of type conversion involved, because a lot of models would require things like specific format. The newer models, multi-model models, can deal with different types of data, but if you're using statistical models, you need the data to be in specific format, specific. Like, for example, you can't just put text when the model is expecting numbers and stuff like that, right? Then data, like even analyzing the data to prep for the models, to figure out, you are collecting tons and tons of data, right? To figure out which ones you should feed to the model, which ones you should discard. Because it's not like I have 1,000 data points, I can use all those 1,000 data points, right? So you got to figure out which ones am I using, which ones I'm discarding, right? And then features engineering. So basically, when you are working with these models, the models expect they were pre-trained with certain data points. An example is, let's say I have a model that predicts housing price, and it wants the age of the house. But unfortunately, my source only has the year the house was constructed. So I don't have the age. So what you will end up doing is, current year, when the house was constructed, you will subtract it and create a feature called age of the house. right? So it's a simple example, and this is where you do things like principal component analysis type dimensionality reduction techniques to get the data tight and kind of like create additional features as well. And then in my example, where I want to focus on something happening in near the White House, I have to also do some geospatial processing. Like I have to pick the pictures that are taken within a certain latitude, longitude within White House, right? Things like that. Last but not least, a lot of the newer models needs vector embeddings. They can understand vector embeddings only, right? So you need, if your data is coming in text format, image format, video format, you need to take it, convert that into vector, and give it to your model. So studies shown, and I have seen in the field working with our customers, mainly in defense and IC communities, is that 80% of your time is going to be spent on this. Why? Because a lot of time on the AI model, somebody has already done that for you. Meta has done that for you with Lava models, right? Google has done that for you. OpenAI has done that for you. So you can use the models as is. But what goes into the model, how it goes into the model, is up to you. As an enterprise person, you are deciding what enterprise data points you're going to use that. Okay, fine. You got all of that, you pre-process the data. Let's say we have some tools, some techniques to do that. We got that, and then we passed it to the AI models, and it figured out an anomaly, right? In this case, it figured a threat in the area of interest. Does it end there? No, because if you have this, your field folks are not going to, it's not going to be useful for them. Like, for example, if in this case, a cop who is responsible for security of the White House area, the information needs to go to them, right? Or let's say if you are a physician looking into a cancer diagnosis, the model can predict that there is a cancer, but it needs to go into the tool that the physician uses so that it can become part of their workflow and their day-to-day activities. So model gives you results, but to make the results productive, you need to integrate that into what the field is using. So there are different design patterns for it. For example, human in the loop, RAG design pattern, agentic AI, agentic RAG. These are different design patterns. Essentially helps you to take all this AI output and integrate that into your apps. This is how you can take a simple object detection use case and make it into a multi-model intelligent workflow, right? And this isn't a made-up use case. This is used by some of the, let's call it some agencies, right? They're using something like this in real world. So that's great. We said we have data processing, we have models, we have something to integrate the models into the end user's toolkit, right? Awesome. Does it end there? No. Because these models, unlike if you're writing a traditional software, you can almost predict like your Java program is going to need this thing, your Postgres is going to need these resources, right? But in an AI model, you can't say that because some models may be GPU intensive. Some models may just need CPUs, right? And some models can be memory intensive. And some are storage intensive, some need move a lot of data in and around, so they're network intensive. And some are like combination of this. So that's why when you go out and hear these speeches in AI conference, you might hear this thing that says AI belongs in cloud, right? I'm sure you might have heard that AI belongs in cloud. But what they really mean is that AI belongs in a cloud-like infrastructure. That's because you should be able to slice and dice any of these things. If your team happens to use a model that is compute intense, you need to give it more CPUs, right? If then you swapped a model, tomorrow a new model came out, and you want to use that model because it's predicting much better, and that model happens to be memory intense, right? So you need to have an infrastructure that's robust enough to slice and dice and give the kind of resource it wants. This is sort of like almost critical for your AI project to be successful. And this is where all the thing you hear about VCF 9 and all the private cloud thing is a big thing if you're talking about doing this on premises, right? If you're doing it on cloud, yes, you have hyperscalers, but if you want to do this on-prem, you need something that can give you elasticity and flexibility with these major components, and that's where this whole VMware things come in. So, we agreed. I hope I convinced you that the 4 fundamental blocks are data, models. Obviously, AI project is all about AI models, right? We said infrastructure is needed for that, so we agreed that. We also said there is data processing, data capability needed for that. And then we said we need apps. I hope I convinced that. So now let's talk about what is VMware bringing to you guys to address this, right? So as for AI models and AI infrastructure, this is where our partnership with NVIDIA comes in. We have something called Private AI Foundation. Private AI Foundation is like our own service, our own infrastructure layer of solution set, plus our own private AI service, where we created services specifically for doing AI stuff. Like, for example, you want to index your documents, or you want to have a RAG type framework. It comes with those services, right? And then, most importantly, we have partnership with NVIDIA, and you get NVIDIA AI Enterprise with that. What that does is you get NVIDIA blueprints, Nemo Retriever and stuff like that. So basically, think of it, right? You want to use a model from open source. You can obviously go download it, but then you have to get all the dependencies for that. You have to get the right GPU drivers for it, because it's not like you just download it and run it. You have to make sure that it has the right GPU drivers, it's secured, it tested, it has proper foundational framework and everything like that. Now with NVIDIA's AI Enterprise, you get that in an executable format, meaning in a container image. So you have all of the model itself, the dependencies for the model, and the drivers and everything like that. So essentially, you have something that you can directly call and execute on and get the output. So that is a big piece of it. The next big piece of it is that you can slice and dice your resources. Like I said, you need to give more memory, you need to give a slice of workload to GPU. You can do all of that with our Private AI Foundation, right? That's kind of like the core of our solution set here. And then what about data and apps? So this is where we are bringing in our Tanzu Data Intelligence solution set. This is all about, when you think about data, remember we talked about volume, velocity, and variety, and all this terabytes to petabytes. So you need some sort of lakehouse type solution so that you can bring in all this data, structured, unstructured, semi-structured, and process that. I will go deep into Tanzu Data Intelligence, and that's really the focus of this too. But essentially, the short version is that it comes with built-in analytical models. It comes in with a data flow pipelines processing engine, and then you have engine for structured data processing, unstructured data processing. You have a metadata catalog. We also have tools that can work with DDIL, like degraded intermittent type network situation, which is important if you are in financial industry, or in fact for most industries, if you are working with, if you have customers in base that don't have robust internet connection, right? So that's sort of our data capability. And then for AI capability, that's where our platform as a service offering called Tanzu Platform comes into the play. Tanzu Platform is really, you want to say anything about data? Did I miss anything?
You have another slide, right?
Yes, we'll talk about that. So Tanzu Platform is really a platform as a service for building apps, and mainly AI apps. So you can put controls on your model. You can expose what models the team can use, what they can't use, right? And you can say how much token they can burn. Basically, you can put governance, you can put cost controls, and it has a self-service portal. So if I want to pick a certain model, they can pick that. And then it also comes with MCP server for building agentic AI type use cases. Last but not least, we also give 280 plus open source software that's all secured and tested, validated. Like for example, you want Jupyter Notebook, you can get it. You want MongoDB or something like that, you can get it. So you get a whole lot of open source software as well along with this solution. So that's sort of like our holistic solution for doing AI on premises, right? Because with private AI, you get the infrastructure needed for deploying AI. You get the AI model from NVIDIA. You get data intelligence for dealing with all of your data workloads. And then you have platform, PaaS, like platform as a service, for building all these AI applications or even integrating that with your existing AI applications.
And real quick, so the MCP server support's going to be an interesting thing because it's really the way you'll securely access your data to provide it to all the AI tools, right? So one thing we're doing there is allowing you to create your own MCP servers and then publish those as a service that anyone else in the organization can then just bind to and use it. So it's almost the promise for the older folks in the room, the promise of Corba back in the day where they said, oh, you write these services and there's a marketplace and you wire them all together, right? That's MCP sort of bringing that to a reality.
Yep, thanks. So to really understand the data capability and then what turns the data intelligence and how do you use that to build a data solution, let's go back to the use case that I talked about, right? So we are taking pictures from our drone, right? The first thing is to understand, like, let's say my use case is I want to figure out if there is any threat, right? To me, a threat is people doing something that they are not supposed to be doing. So first I want to know whether there are any people or image like cars or trucks in my picture, because that's what I think as a profile for doing further analysis. So I can do a model like YOLO, which is you only look once type model. It's an advanced model which can do object classification. It can tell you whether there is a car or people or something like in that. And then you can take that and run it to a Lava model, which is more like a descriptive model. So essentially you can add a prompt and say, describe to me how this car and what are they doing or something like that. So you can basically add this image and a prompt and give it to a Lava model. Lava model will kind of explain what is going on in the picture. In this case, it says a person appears to be unloading an equipment from a large truck near a temporary structure. That's what Lava model does for you. You don't have to do anything. It's pre-trained. It tells you, right? And then you run it through a tree of thoughts framework. It isn't a model itself, but it's a framework where it sorts of goes through different reasoning to figure out what could be the plausible explanation for that, right? And then the tree of thought, and it could use Lava, it could use another GPT model. That's where you figure out, remember I talked about you will do model selection and stuff like that. This is where that comes into the play. So in this case, let's say we just call Lava again and say, hey, reasoning 1, go look for this, reasoning 2, go look for this, right? That's sort of going to the tree of thoughts. And then at the end of it, the model concludes that, hey, look, this is an anomaly because I see a person in the image, and that person seems to be wearing a military gear, unloading equipment from a truck parked near a remote structure. So all these things seems like a threat to me, right? So that is the conclusion of the tree of thoughts. So you store that somewhere. Now you want to remember what I said. You detected a threat, but you have to really put it in front of the analyst so that he or she can go take some action on it, right? So to do that, I really have to highlight which part of the picture that there is a threat. So I'm using a model like Grounding Dino. What this can do is, given the prompts, it can actually really put boundaries and say, this is the car, this is the people that I'm suspecting, right? And then you integrate that into your analyst workbench, and you can use a human-in-the-loop type framework so they can sort of go and say, well, this is okay, this is just some people, dumping into an Amazon inventory or something like that, or this is something that is a suspicious thing. And you want more data to support this. So you dumped all the raw images because the analyst may want to see the actual image that was processed by the models to make sense of it. So you probably dumped that somewhere and then you are feeding it. So this is how you can take that whole use case and bring it into something that's actionable. Now, if you take this and see the capabilities needed to implement this in a production scale, you need some ingestion capabilities, right? We are capturing all those pictures, so you need ingestion capabilities. We need all these models like YOLO, Lava, and all that. And some of this can be even open source models that are in the public. You can do that. So that is there. And then you need a lake house for storing all these things. And you need some sort of container for your apps and some real-time data to integrate all this. So this is sort of the capabilities that you need to process this, right? So Tanzu Data Intelligence essentially is really centric around massively parallel data lakehouse. This is going to help you store all those structured, unstructured, semi-structured data in different formats. You can store it in Avro, Parquet, or open table format, all different types of format. And then we also give you capabilities to ingest the data, ingest all this data. We have something called Tanzu Data Flow that can help you build data pipelines to get data into the lakehouse. And we also have something called federated data access. See, sometimes in organizations, you don't want to always get data into your lakehouse. You may have a need to just go and get data during runtime. An example is, let's say you have a PII data sitting in a PII zone. You don't want to put that in your lakehouse because that means the lakehouse has to govern it and control it and all that. But you are okay for a model to use that during the runtime. So you can, in this tool set, we have this federated data access capability. What this allows is the lakehouse can go grab it during runtime, process it, and then discard the data. So you don't keep a copy of the data and all that. And then we have inbuilt AI/ML capabilities. We have container services. So essentially all the capabilities we saw to implement a use case, a real use case that we saw earlier, those are there in this lakehouse thing. This can run on private cloud or public cloud, even though we are VCF native, in the sense most of our integrations are built for natively working on VCF. But if some of our customers have deployed this on Amazon, one of our customers is currently evaluating this on Google Cloud. So this can work. This is a software solution at the end. At the core, it is a software solution. But there are a lot of integrations. We take advantage of developments in VCF, like vSAN improvements and stuff like that. So it starts of make use of that, right? So with this, we are only, I said this is a private AI and all that, but you can also build modern applications because this supports HTAP. HTAP stands for Hybrid Transactional and Analytical Processing. So one of the big bank, Wall Street firm, uses this for transactional processing. Tons and tons of transactional thing, right? You can do BI workloads. It's not always AI. A lot of times you just need to produce a simple report of how many products I sold, right? How many stores, what was the revenue by region, things like that. So you can do that. And Gen AI, agentic AI that we talked about. So these are the specific capabilities of the lakehouse. It scales linearly. You don't have to start with a really huge system. You can start with a small system and then scale it. It can scale from like few terabytes to petabytes. Like IRS uses a component of this for tax processing. SSA uses a component of this for processing all of the SSA claims. FRB uses this for their economic analysis. Like anytime you see this economic policy coming out, we play a small role in it because some of those analytics happen in our component. Right? That's just the government. There's also IC use cases, the human intelligence type use cases. Air Force uses this for cybersecurity. Morgan Stanley uses this for their risk management. So there's lots and lots of clients that are using this, right? Millions of queries per day, still lots of queries. Thousands of users can share the same environment. Obviously, if you have a lake house, you want most of your enterprises to use that. So we have capability for all that. You can load data either in batch or real time. You can take your Kafka stream, point directly to the lakehouse and let it sync into it, or you can load it in batch. And then we have integrations with Spark, so you can run your machine learning or AI/ML loads directly. Here, Dan has an amazing demo in our booth
and this architecture is really built, it's years and years of customer interaction to build this, but it's really an 80-20 rule, right? 80% of my data is going to be outside of my warehouse that I want access to, 20% internal, but 80% of the access of the data will be focused on the warehouse. So in the past, there's been Hadoop solutions that focused on storing everything, and then they tried to build SQL in there, right? But if 80% of your access wants SQL, let's use a real SQL engine for that, and then provide it access out to where the 80% of the data lives. So it's a nice architecture built over years, and we've tried the other ones and sort of settled on this one, and it's been very successful.
Absolutely. So we have customers using this for AML, money laundering type graph analytics use cases. I already talked about geospatial. You can do that. You can do machine learning. There are 75 out-of-box functions, starting from all the way from your basic regression models to deep learning models. In addition to, once you put this with the private AI foundation, you can use all of the models that NVIDIA gives us. So there's a lot more flexibility with that. And then, like I said, you can process all these things. Some of the things are use cases that our customer use today are risk and fraud analytics, cybersecurity, Intel use cases, computer vision, which we saw. So,
and he talked about the demo. So in our booth, or we have a data intelligence session tomorrow where I'll show it live. Right, we have a demo built that uses the data lakehouse and HDFS, but it's really designed around one of the biggest telemetry generators that we have in our lives now, which you're all holding and taking pictures with, right? So insurance companies, like all the commercials now, hey, install this app, get safe driver discounts, right? And how do they do that? Well, they're sending telemetry data about your speed, whether your phone's moving while you're driving, and X, Y, Z axis of your car. All this data is streaming somewhere. So the demo is basically showing that whole process through the lakehouse, letting Greenplum then run a machine learning model against that to generate safe driver scores.
And this may sound too good to be true that we are claiming all of that. That's because it's really built on two solid products out in the market, right? Greenplum. Greenplum is a massively parallel database, which has been out there for 15 years now. And then the second component is Hadoop. I'm sure you all heard about Hadoop. So the secret sauce really is this thing called connector. So we have Greenplum, we have Hadoop, and then we have an optimizer that is aware of, okay, this particular workload is in Greenplum, this particular workload is in Hadoop. So I distribute how to get the data out. And the distribution and then the pushing and pulling happens through this connector. That's our secret IP, like the engineering thing in there. So it's kind of like really saying, Greenplum is really good at structured data processing. Hadoop is really good at unstructured data processing. If we can integrate them and make sure we take the complexity out of moving data in and out and figuring out where to put what, this product takes care of that for you, right? So the user really, they don't have to figure out, am I talking to Hadoop or this? So we just kind of like leave all of that out and say, you just give me your data. I'll put it, I'll process it, I'll get the results for you. Okay, that's the idea behind this. It's kind of like basically saying these are engineered by us, right? We have solid engineering, so why not roll that into that integrated product? But on top of it, we know that just processing data alone won't be enough. So we also are bringing in some metadata like catalog tools, so you can actually interact with the catalog instead of interacting with the data layer. So that's also part of this, right? This is a RAG use case that one of our customer is using this product for retrieval augmentation and generation type thing. So basically, if you want to use your enterprise data along with your LLM, and you get a prompt from the user, you have all of your enterprise data stored as embeddings in this lakehouse, and then the prompt is enriched with the appropriate part using a vector cosine search. So it gets all the relevant vector embeddings from the lakehouse, and then it sends to the model. So now the model, the LLM has both the user query and related vector embeddings. The model will give you more tailored solution. So this is a framework. Again, computer vision model, so you could do that. This is how it really looks like from a kind of like the foundational capabilities standpoint, if you look at the whole stack. So the building blocks is our VCF. You have multi-tenancy, your GPU sharing, your resource sharing, and all of that, and then all of the observability that comes with it. Then on top of it, we have private AI services like a model store, model runtime, model registry, and all that. NVIDIA, like I talked about, it gives you the microservices, the Nemo retriever, your blueprints, operators, and stuff like that. And then for all the data processing, we layer Tanzu Data Intelligence for the data lakehouse capability. And then Tanzu Pass, remember I said like we have all this bunch of models, so we have to handshake between the models, right? Like we say, do the object classification, then filter out, do this description, do the reasoning. So you need a pass to kind of coordinate all of that. That's our Tanzu platform. So with this, you get a full stack all the way from your infrastructure to models, to data, to apps. So why, you may ask, why a private data lake for, and again, like this is all about private AI. To be honest, if you want to do this on cloud for your open thing, there are lots of other solutions. You could use Databricks, you could use Snowflake and all that. You could use us too. We like I said, we are available on cloud, but we are more native to VCF. If you go out and if you want to do this AI implementation on premises, and there are a lot of use cases, there are a lot of data privacy and data sovereignty reasons why you would do this on premise. If you want to do it on premise and if you want a comprehensive solution like this, there isn't one in the market except this. You have bits and pieces of this because most providers are focusing on public cloud, not private cloud. But this is our bread and butter, so we sort of building this and focusing on that. So you have choice and control. Basically, you control data, you control algorithms. Any data you put into ChatGPT or anything you send out to public model, the model learns from it, right? Basically, the model gets your IP if you have any IP going there. But in this case, you are controlling it. It doesn't leave your premises. You can govern, you can put all sorts of compliance, you have audit control, you can explain why certain things happened in a certain way. Cost is another big thing. If you put it on VCF, A, you are leveraging your existing infrastructure. B, it's very predictable. You know exactly what the cost is going to be. In fact, we are seeing customers coming back from cloud because of the egress costs and unpredictability of that. So there are reasons why you do that. And the often overlooked part is the ELA pricing, because when you do this as a bundle and when you talk to VMware as a big thing, the pricing of this is a lot more affordable than using a cloud product out there. And then lastly, it's the scale, right? You can scale this starting from a really small to petabytes and whatnot. So this is a reference architecture from the use case we talked about, like how it is done in production, is you have all these data points that are streamed through, in this case, RabbitMQ, but they also use a combination of Kafka and RabbitMQ for streaming data into the lakehouse, and then it lands in the lakehouse. In the lakehouse, it goes into a S3 storage. That's your raw data layer. If you think about the medallion architecture, like bronze, silver, and gold. So your raw data in this lakehouse really goes into a S3 storage. And then from there, they curate and they take the data needed and create a data model like a structured data warehouse. That goes into Greenplum. And all of the images and the unstructured data goes into Hadoop. And then the whole training happens with the private AI foundation using the NVIDIA models. And that whole processing is orchestrated using Tanzu platform. And these are some of the models that are used, like for classification, detection, segmentation, and stuff like that, right? So essentially, this is sort of like you have your IoT device, you get the data in, stream it. This is like, it keeps coming on-prem. The data keeps coming, streaming into the lakehouse. And then you train the model, so the model keeps keeps looking at it and make real-time inference. And that's where Gemfire comes in. Gemfire is a product that can do like DDIL type active sync, meaning if your network goes down and it comes back up, it can still sync the data and keep it in sync. So this is a customer of ours using this solution, right? As you can see here, they got all kinds of stuff: a camera, temperature, pressure gauge, and all kinds of stuff on trucks. And they have about 200,000 trucks, and they want to get all this data, right, to stream it real time. and make sure that they can manage the fleet. Like, for example, one is running low on tire pressure. So maybe my maintenance guy will be ready to fix that. Or an oil is down, or what, things like that. So basically you have data and you have maintenance activities on it, right? And this customer is collecting 25 gig per hour. And like 380 terabytes, right? So it's a lot of data. And this is how they do it. Again, the same architecture I showed you. They stream it through RabbitMQ, all of those sensor information into a data lakehouse. But in this case, they aren't using the full data lakehouse features. They're just using the Greenplum component. And they want real-time dashboarding so people can see what is going on real-time with all these trucks. So they put the data onto Gemfire, which is an in-memory data grid, and then they can visualize this. You can use Superset. You can use any sort of visualizing tool on that. So again, this kind of shows you the power of all this integrated solution where all these products are architected to work with each other, interoperable, and on-prem too. Because you don't want your sensitive information to be out and locked in a public cloud. And if this interests you, and if you want to know more about what we are doing in the AI space in terms of data and apps and stuff, here are other sessions. We have some booth theater session. My colleague Greg is here. He's an awesome architect. We're going to talk about some of those sessions. And Dan, you have a bunch of things coming up too.
Yep,
You want to highlight any?
Connecting the dots, the RAG session. So I'll do a live RAG demo and sort of explanation of how the technology works behind it and the best way to integrate it. So that'll be a booth theater session. I believe that's tomorrow.
Yep.
And there's also a data intelligence session.
Yep. Perfect. So that's all I have for you. Thank you so much again for joining us. Please take the survey if you can. Thank you.